Today, let's take a look at this problem. Generally, if a child hasn't received any mathematical thinking training, this problem can be quite difficult. Today, I'm going to teach parents a very good method that combines diagrams. So let's first read the problem carefully. A few children at night shoot arrows onto horses, and there is a pile of red feather arrows. If each person gets 3, there are 6 left over. If each person gets 4, there are 2 short. So how many children are there and how many red feather arrows are there? Alright, first we see that this pile of red feather arrows is distributed to the children twice. So how is the first distribution done? In the first distribution, each child gets 3 red feather arrows, right? So each child receives 3 red feather arrows and so on for each child. Then there are 6 left over, 6 extra, so that means there are 6 more than needed. Now, in the second distribution, each child is given 4 red feather arrows, 4 red feather arrows, and so on for each child. But this time, there aren't enough, there are 2 red feather arrows missing. There are still 2 red feather arrows short in order for each child to get 4 red feather arrows. Alright, so we need to make up for what's missing. We need to add the missing ones. Because the number of children is a constant, the number of children doesn't change. In other words, the number of children stays the same. No matter how many times you distribute, the number of children remains unchanged. So, in this situation, we know that for the 2 that are missing, we need to find 2 more to make up for them. If we find 2 more to make up for the missing ones, then how many will we have in total? So in total, we will have 6 plus 2, which means 8 more in total. This should be clear. There are a total of 8 extra red-haired orders. And here we can see that in the first distribution, each child received 3 red envelopes. In the second distribution, each child received 4 red envelopes. In other words, from the first distribution to the second distribution, did each person receive 1 more red envelope? Then 1 more was added. Right, everyone got 1 more. That's how it is. We can also understand it this way. All 4 extra people were added here, and each one was given out 1 by 1. So that makes 6 distributed, right? But there are still 2 missing, so it still needs 8, meaning there are 8 extra people in total. Alright? It's the same logic. So in this way, each person actually, how many more does each person get? How many more people are allocated to each? Well, it's simple. As you can see, 4 minus 3 is equal to 1. So 3 equals 1, which means each person gets 1 more. During the second distribution, we need to calculate the total number of children. So in total, how many children are there in total? Okay, that's 8 divided by 1, which equals 8. So there are 8 children, right? Because there are 8 extra. And each person gets 1 more, so we divide by 1. And that's how we get the answer. When we calculate to this point, we can easily know how many red hair orders there are. So how many red envelopes are there? The number of red envelopes is currently we can use either the first or the second distribution to calculate this. Let's use the first distribution. In the first distribution, there are 8 people. Each person gets 3 red envelopes, and there are 6 left over. Alright, so we can conclude that there are a total of 30 red envelopes here. We've calculated it if you get it. If you learned it, please give Teacher Sunny a like and follow.